well. This is chapter 10.1, simplifying radicals. It can also be called simplifying square roots. Your assignment will be page 539, 8 through 11, 12 through 19, and we'll be doing the exact and approximate answers. So on page 538, the checkpoint we have is where we're going to start doing our work. Before we do that, let's look at what a radical is. The square root of 16, it's a number that's inside a radical symbol, is called a radical or radical expression. And the number inside the radical symbol is called the radicand. All right, we're going to start with number 1, which is the square root of 27. Okay, so on page 538 checkpoint, we're going to be doing those problems. And before we start that, again reminding you that this is a radical symbol, square root symbol. The whole thing, square root of 16, is a radical, and the inside value, the value inside the square root symbol, is called a radicand. So on number 1, we have the square root of 27. We want to think of perfect squares. There's the square root of 4, which is 2, the square root of 9, which is 3, the square root of 16, which is 4, and the square root of 25, which is 5. We want to think of one that will divide into the square root of 27, meaning you'll have two factors, and one of them will be a perfect square. So the square root of 9 times the square root of 3 gives you the square root of 27. Square root of 9 is 3, so 3 square root of 3 is your exact answer. On the calculator, we simply plug in the square root of 27. We know that the square root of 27 is between the square root of 25, which is 5, and between the square root of 36, which is 6. It's much closer to the square root of 25, so we know the answer is going to be slightly more than 5. And when we plug it in the calculator, we get a long number. We're rounding to the tenths, and it's approximately 5.2. That's our approximate answer, whereas 3 square root of 3 is our exact answer. Now, on number 2, the square root of 46, you don't always have a number that can be simplified. None of the perfect squares, 4, 9, 16, 25, will go into 46. So square root of 46 is the simplest form. That's our exact answer. We put it into the calculator. We get rounded to the 10th, 6.8. That's our approximate answer. And we know that the square root of 36 is 6, and the square root of 49 is 7. Square root of 46 is much closer to the square root of 49, so 6.8 makes sense because it's very close to 7. Okay, the square root of 8 has the perfect square in it of 4, so the square root of 4 times the square root of 2 is the square root of 8. Square root of 4 is 2, so 2 times the square root of 2 is the exact answer. If you were to put the square root of 8 into your calculator, it would be approximately 2.8 when rounding to the tenths place. In order to tell if this is reasonable, you know that the square root of 8 is between the square root of 4, which is 2, and the square root of 9, which is 3. Square root of 8 is much closer to the square root of 9, so 2.8 is almost 3. It makes sense. Number 4 is the square root of 97. If you were to divide 4, 9, 16, 25, and so on into 97, you would see none of them went in evenly. So the square root of 97 is, in fact, the exact answer. Now, the square root of 97 is between the square root of 81, which is 9, and the square root of 100, which is 10. Much closer to the square root of 100, so it's going to be very close to 10, but not quite as much. When you put it in the calculator, you get approximately 9.84, which rounds to 9.8, which is close to 10. Okay, so number 9, the square root of 20, is the product of the two factors, the square root of 4 times the square root of 5. Square root of 4 is 2, so 2 times the square root of 5 is the exact answer. When you plug in the square root of 20 into your calculator and round it to the tenths, you get this approximately 4.5. The square root of 20 is between the square root of 16, which is 4, and the square root of 25, which is 5. It's almost in the middle, so 4.5 makes sense. Number 10 is the square root of 8. Square root of 8 is the square root of 4 times the square root of 2. Square root of 4 is 2 times the square root of 2 is your exact answer. Square root of 8 is approximately 2.8, since it's between the square root of 4, which is 2, and the square root of, the 9, which is 3. It's going to be a reasonable answer. Number 11 is the square root of 75, or square root of 75, which is the square root of 25 times the square root of 3. The square root of 25 is 5, so 5 times the square root of 3 is the exact answer. It approximates to 8.7 on the calculator, rounded to the tenths place. The square root of 64 is 8. The square root of 81 is 9. It's a bit closer to the square root of 81, so 8.7 makes sense. Number 12 is the square root of 112. Now this one wasn't as easy, but had you divided, you would have found quickly that the square root of that 16 goes into it evenly. So the square root of 16 times the square root of 7. Square root of 16 is 4. 4 times the square root of 7 is the exact answer. When you approximate the square root of 112 and round it to the tenths place, you get 10.6. It's between the square root of 100, which is 10, and the square root of 121, which is 11. It's kind of right about the middle, so 10.6 makes sense. Onto this assignment, we're going to add on pages 539 to 540, 20 through 31. We're now going to do some examples that will help you with that. Okay, this is page 537, example 2. Now we're going to actually use the Pythagorean theorem, and that'll be part of learning to simplify radicals. It also will tie into the trigonometric functions sine, cosine, and tangent. So we have a squared plus b squared equals c squared. That's the Pythagorean theorem. A and b are the legs. Now typically the vertical leg will be a and the horizontal leg will be b. C is always the hypotenuse. So a squared is going to be the square root of 2 squared plus b squared, which will be the square root of 3 squared equals c squared. Now, the square root of 2 times the square root of 2, that's the square root of 2 squared, is the square root of 4, which equals 2. Square root of 3 squared is the square root of 3 times the square root of 3 equals the square root of 9, which equals 3. And what I'm hoping you're seeing is these 2's are the same as that 2. These 3's are the same as that 3. So as the numbers get larger, that you won't have to multiply them together to figure out the pattern. So we know the square root of 2 squared is 2. The square root of 3 squared is 3 equals c squared. 2 plus 3 is 5 equals c squared. Now again, you're using your properties of quality. The inverse of a square is a square root. So we take the square root of c squared, which is going to give you c, equals the square root of 5. Now that's your exact answer. But it can be approximated. So you just take the calculator and put in the square root of 5. And the square root of 2 is, the square root of 5 is 2.2, is approximately c. It's not going to be exact because you're rounding, so this is the approximate answer. Okay, now we're going to go ahead and do page 539, 6 through 7. And you've got 2. Actually, the c is not, I'd like you to draw the picture in your notes. The c is not given. And then we're going to, this is 2, this is 4. Those are your legs. A is typically the vertical, B is the horizontal, and this is obviously C. I'm adding that in. And you're going to use the Pythagorean theorem, a squared plus b squared equals c squared. Go ahead and shut off the recording for a moment, pause it, go ahead and solve, find your exact answer and your approximate answer, and then turn the recording back on to check yourselves. Okay, so you have 2 squared plus 4 squared equals c squared. 2 squared is 2 times 2, which is 4. 4 squared is 4 times 4, which is 16. 4 plus 16 is 20 equals c squared. To isolate the c, you take the square root of c squared. The inverse operation is a square root when you have a square. And c equals the square root of 20. Now this isn't finished because within the square root of 20 is the perfect square of 4. So the square root of 4 times the square root of 5 equals c. And then the square root of 4 is 2. So 2 times the square root of 5 equals c is the exact answer in simplest form. If you approximate it, you end up with 4.5 rounded to the nearest tenth is approximately c. And then let's go on to the next portion. Okay, we're going to do number 5 together. Square root of 3 times the square root of 5 equals the square root of 15. There are no perfect squares within the square root of 15, so that is the exact answer in simplest form. Again, we're doing these a little out of order. This is page 538, 5 through 8, but that doesn't matter. It doesn't really matter that they're out of order. Now, you're going to do 6, try it on your own, but let's go ahead and do 7 together first. So square root of 3 times the square root of 27, we have the square root of 3, doesn't have any, excuse me. That's going to be 3 times 27. 3 times 20 is 60. 3 times 7 is 21, so that's 81. And the square root of 81 is 9. There's actually two different ways to do that. You could take, it takes a lot more steps, but you could go the square root of 3 times, I'll just do it off to the side in another color. You could go the square root of 3 times the square root of 9 times the square root of 3, because the square root of 9 times the square root of 3 is 27. And then you would say, oh, the square root of 3 times the square root of 3 is the square root of 9 times, and then the square root of 9 is going to be 3. And again, there's a lot of different ways to do this. Square root of 9 is 3 times 3, which equals 9. It's definitely faster to do it the other way, but this is another way you could have done it. Okay, I'd like you to pause the recording, do number 6 and do number 8, and then turn the recording back on to check your answer. Number 6 is the square root of 11 times the square root of 6, which is the square root of 66. No perfect square there. No perfect squares fit into or divide into the square root of 66, so that's the exact answer. When you get to 8, however, you've got 5 times the square root of 3 times the square root of 3. Square root of 3 times the square root of 3 is 9. Square root of 9, excuse me. 5 times the square root of 9 is 5 times 3, which is 15. And let's go back up and look at what your assignment is. So the first part of the assignment is page 539, 8 through 11, then 12 through 19. Now you need to do both exact and approximate answers. And then onto that, you're going to add pages 539 to page 540 and do 20 through 31. The notes on the left should help you do all of those problems. Refer back to the recording if you have any difficulties throughout the assignment.